Today we're going to talk about the cosine ratio. First we're going to do a warm-up. Okay, so if I've got 0.345 equals x over 7. Now the first thing I'm going to do to get rid of that 7 is I'm going to multiply both sides of the equation by 7. And by doing that, I can have this 7 on the top and the bottom cancel each other out. And then I'm left with 7 times 0.345 equals x, because that 7 canceled out that 7. And so then I take out my calculator and I say, okay, 7 times 0.345, and then I get 2.415. So x equals 2.415. Okay, let's do the next one. Okay, so we've got this. So I could multiply x on both sides, or think about this as being over 1, and if I cross multiplied, I would have x times 0.782 equals 10. And because if I, like I said, if I cross multiplied, I would have x times this equals 10 times 1. Okay, and then in order to solve for x, I have to divide both sides by 0.782. And the reason for doing that, once again, is to make this 0.782 on the top and bottom cancel out. And then I end up with x equals 10 divided by 0.782. And I can type that into my calculator. 10 divided by 0.782, and I get 12.788. So x equals 12.7, we'll just call it 79. Okay, you might want to hit pause and check your work, and let's go on to the next one. Okay, so we're going to solve this example like we did in class. So we're going to solve using sine ratio. Now sine is the opposite over hypotenuse. Now wait a second, this is not opposite, this is adjacent to the 34 angle. This is adjacent and this is the hypotenuse. So if I'm going to use sine and we're going to use opposite like we did in yesterday's work, what I'm going to have to do is I'm going to need this to be the reference angle for this to be opposite. So, so this reference angle, how do I figure out this reference angle? Well, what do all the angles in a triangle add up to? 180. So I could do, and this is 90, right? So these two here are going to have to add up to 90. So 90 minus 34 is going to give me 56. So this angle here is going to be 56. And so using the way that we did this earlier, we've got opposite, we've got our hypotenuse. So then we can say that sine of 56 equals opposite over hypotenuse. And so then I get my calculator. Sine of 56 is 0.829. Okay, and then to get rid of this 13.5, we multiply it on both sides. And the reason we're multiplying that on both sides is to make this and this cancel out. And so then I end up with x equals 13.5 times 0.829, and we get 11.2. Now there's an alternative way to solve for this, and I'm going to show you this alternative way. And this alternative way is using something called the cosine ratio. So if I've got my reference angle right here, and if I'm dealing with the adjacent side, so adjacent means it's touching, right? So I've got my adjacent side, and I've got the hypotenuse. So if I know my adjacent side and I know my hypotenuse, then I can use the cosine ratio. So this fraction here can be converted into a decimal, and this decimal has a relationship with the angle. So for example, if I've got the fraction turns into a decimal that's, for example, 0.906, then I know that the angle degree is going to have 25 degrees. So you can print this from Canvas. Or you can use your calculator too. So let's solve this problem together. Here we have the adjacent side. It's adjacent because it's touching the reference angle. And here it's across from the square, so this is the hypotenuse. Okay, so now I can write, since we're using adjacent and hypotenuse, we're going to use cosine. So cosine of this angle 57 equals adjacent over hypotenuse, so x over 11. And then I can use my calculator, cosine 57 degrees, and I get the decimal of 0.5446. So basically, using the calculator, I'm substituting or replacing cosine 57 with this decimal, and we can find it here. 57 degrees is right here, and cosine 57 is 0.546, which is exactly what we have here. So you could either use the table, you could use the calculator to convert. And this is equal to x over 11. So in order to solve for x, like we did before, I could put this over 1, and 1 times x is equal to this decimal times 11. Okay, so let's do it. This decimal times 11, and I get 599. So now I'm going to get x equals 5.99. All right, let's do the next one. Solve for x. Okay, so here's my reference angle. Across from the square is the hypotenuse, right? There's the square. And then once again, this is adjacent. So I'm going to mark it with an A. So when you have adjacent and hypotenuse, you're going to use cosine. So we can say cosine of 39 degrees is equal to adjacent over hypotenuse, so 3.81 divided by x, because we're going to have adjacent over the hypotenuse. And so now cosine of 39, enter, and I get 0.777. Excuse me. So we get 0.777 equals 3.81 over x. And let's just say I wanted to check here. So cosine of 39, is 0.777. So it really doesn't matter if you use the chart to convert the angle to the decimal, or if you use the calculator. They both will do the same thing. Okay, now we want to solve for x. I could put this over 1 and cross multiply, so then I get 0.777 times x equals 3.81. Okay, and now to solve for x, I'm going to divide both sides by 0.777, and then that will cancel out this on the top and the bottom. And then I get x equals 3.81 divided by 0.777, and we get 3.81 divided by that number, and I get 4.9. Okay, last question, inverse cosine. So once again, we have the adjacent side, and we've got the hypotenuse. Hypotenuse is across from the square. So whenever you have adjacent and hypotenuse, you're going to use cosine. So cosine of x equals adjacent over hypotenuse, so 2.93 over 5.32. So I can, now we're trying to find the angle, so I can do the division there. So 2.93 divided by 5.32, and I get 0.5507. So cosine x equals 0.550. I guess that rounds up to 8. Okay. So let me show using the chart first. And 0.5508, 0.5508. Okay, this is pretty close. 0.59, and that's 56 degrees. So this means x is going to be equal to 56 degrees. Okay, now let's do this using a calculator. Okay, so let's say I didn't have the chart, I just want to use my calculator. Okay, so in order to use the calculator, I use something called inverse function. So we do second cos and if you do second cos, that's going to give me, so it's going to look like this. So second cos gives me cosine with this little negative number, and I'm going to put the decimal here, 0.5508. And then it gives me the angle, and that tells me that my angle x equals 56.5 degrees. Okay, so, and this angle is more accurate than this value here. But either answer is acceptable. It shows me that you know what you're doing, and good luck with your notes, and rewatch this if you need extra help.